All right, in this example, we're going to find local max and local min for f of x equal x times square root of 6 minus x. And to do that, we're going to need the derivative of f so we can find the critical numbers of f. And I'm going to remind you, because we're going to be taking the derivative of the square root, that we do have this special application. The derivative of square root of x is 1 over 2 root x, which we can find using the power rule if we write x to the 1/2 power, but it's more convenient in this case to use this rule instead. So now to find the derivative of f, we're going to use the product rule, and for the product rule we have f prime g plus f g prime. So f prime is 1, because that's the derivative of x, so here's times g, plus f, and now we're going to take the derivative of the square root of 6 minus x. So we're going to use the derivative rule for square root of x, but also the chain rule. So we're going to have 1 over 2 square root of the inside stuff, 6 minus x. And then we have to multiply by the derivative of 6 minus x, and that derivative is negative 1. So altogether we have square root of 6 minus x plus x times negative 1 over 2 square root of x. We need to combine these. I'll first rewrite this as square root of 6 minus x over 2 square root of 6 minus x. But in order to combine those, we need a common denominator. That common denominator is going to be 2 times the square root of 6 minus x. So we're going to get 2 times the square root of 6 minus x times the square root of 6 minus x over 2 square root of 6 minus x plus, sorry, not plus, that will be minus, x over 2 square root of 6 minus x. And overall, when we combine all of that, when we multiply the square roots together, that's going to give us just what's underneath, the 6 minus x. We're going to have 2 times the quantity 6 minus x in the numerator, and 2 square root of 6 minus x in the denominator. Distributing in the numerator is going to give us 12 minus 2x minus x. So overall, our derivative is 12 minus 3x over 2 times the square root of 6 minus x. And that's the derivative. Now, since I need the board space, I'm going to go ahead and write that down, and then we will continue. So we have f prime of x is 12 minus 3x over 2 times the square root of 6 minus x. Now, we're going to use the critical number, so that's where f prime is 0 or where it does not exist, in order to break up the number line to test positive and negative. But one thing we have to be aware of here is that the domain of the function is not all real numbers. Because we have the square root here, we know we're not allowed to have a negative real number under the square root, so we need 6 minus x, which is under the square root, to be greater than or equal to 0. So that means 6 is greater than or equal to x, or x is less than or equal to 6. So when we're talking about the number line, we're really only talking about values up to 6. Okay, so when we're looking for our critical numbers, and we put them on the number line, that is only going to be going up to 6. Alright, so for our critical numbers, that's where f prime of x is 0 or f prime of x does not exist. For where it's 0, because we have a fraction, we're going to take the numerator of the fraction, we're going to set that equal to 0. So we get 12 minus 3x is 0, so that means x is 4. There's one of our critical numbers. And then for f prime does not exist, that's where the denominator might be 0. So that we need to worry about where x minus 6 would be 0, so that would be x equals 6. We've got two critical numbers. We've got 6 and then 4. So we can mark 4 on the number line as our other critical number, and then we're ready to keep going. But again, I need a little more space, so I'm going to erase. Okay, so we know our two critical numbers are 4 and 6, but 6 we don't have anything on the other side, so that cannot be a local max or a local min because we don't have something on both sides of the graph. But we still need to know whether the derivative is positive or negative in that space. I'm going to label here f prime and f. In fact, I'm going to move this whole thing up because it'll be easier to see. Alright, 6, 4, f prime, f. So I'm going to pick x equal 5 because that's a convenient value to plug in. And we're going to plug this into the derivative, remember. So we're looking at 12 minus 15. So that's going to be negative in the numerator. And then in the denominator, that's going to be positive 2 times the square root of 6 minus 5. So the square root of 1. So that's all positive. So overall, we have negative over positive, which will give us negative in that segment, which means that the function is decreasing because the derivative is negative. So it looks like that. And then in this range over here, I want to pick another convenient value. And this time, we're allowed to pick anything we want in here, but I'm going to pick x equal 2. And the reason I'm choosing 2 is because when I plug in x equal 2 right here, not that this really matters that much, but when I plug in x equal 2, I'm going to get 6 minus 2 is 4, and I know easily the square root of 4. But what we really care about is positive or negative. When we plug into the numerator, we're going to get 12 minus 6, which is 6, so that's positive. And then in the denominator, we're going to have positive 2 times the square root of 4, so that's also positive. So we get positive over positive, which overall is positive, which means that the function is increasing in this segment because the derivative is positive. So we see that the function switches from increasing to decreasing. The derivative switches from positive to negative. So right here we have a local max at x equal 4. But we do not have a local min. So we end up with a local max. Enjoy the view of my back here for a second. At x equal 4 and no local min. And that can happen sometimes.